Alright, so we're going to be talking about composition of functions today. So this is something you did do in Algebra 2. So it's going to be a little review. It might make it a little bit harder than we did in Algebra 2, but mostly going to be what you did then. So for a composition of function, that's when you take two functions and you squeeze all of them together to make one new function, right? So what we do is we have f of g. When it's written this way, with the dot in the middle, it's the same as writing it this way. It's just two ways to write the same thing, right? What you do is you take the x that you're getting, you put it into the g, so the one in the middle. You start in the middle and work your way out, right? So put the x into the g and then put that into the x, right? So you're kind of working it in a series, right? Start in the middle, work your way out. So I'm going to show you, it's best to learn through examples, so we'll start with this one. So here's f function and our g function, right? So we're going to do three different things. So first we do f of g of x, right? So we're taking f of g of x. So the g function is going inside the f function, right? So first I'm going to write this way. So in here, instead of writing g of x, I'm going to actually write the equation. So g of x is x minus 4. So I'll put that there. All right, so now we can see that we're putting x minus 4 into the f function. So my f function is here. So what I'm going to do first is I'm going to rewrite it, but where the x is, I'm going to put parentheses in that spot. So this is what our f function says, x squared plus 1, right? So instead of putting x here, we're going to put x minus 4 here, right? So I just put the g function inside the f function. Once you do that, then you just have to simplify, right? So first we're going to take care of my x minus 4 squared, which we did yesterday. So x squared minus 4x minus 4x plus 16 is x squared minus 8x plus 16. All right, I still have that minus 1, or plus 1, sorry. So add that to the end. X squared minus 8x plus 17 is the final answer. There we go. So nesting your functions inside of each other. So g inside of f. In the next problem, we're going to do it the other direction. Now f is going to be inside of g. All right, so first I'm going to write what my f function says. F is x squared plus 1. It's going to go into g. So now g says to do whatever f is and minus 4. Right, so our f is x squared plus 1. X squared plus 1 minus 4. X squared minus 3 would be the answer to that one. So that's there. So we did it both directions. What you can also do is use a number instead of an x. Right? So for this one, we have f of g of 2. First thing I'm going to do is I'm going to put 2 into the g function. So g says to do x minus 4, so I'll do 2 minus 4, which is negative 2. Now I'll take that negative 2 and put that into the f's function. F says to do x squared plus 1, so I'll do negative 2 squared plus 1, which is 4 plus 1, or 5. So if you're doing it with a number, take the number and evaluate it in the first function. Then take your answer and put it into the second function. Right. And there's that. So those are 3 types you'll do. You can you'll get 2 equations. You can put them in 2 different orders, so f into g, g into f, or you can put numbers into them. Right. Well, there's some more examples. So here's two new functions. We've got f of x is 3x plus 1, and g of x is 5 minus x squared. So we're going to do g of f of x. Okay. So f of x is 3x plus 1. So that's what I'm going to put into g. So this one's going into this one. So instead of 5 minus x squared, I'm going to do 5 minus 3x plus 1 squared. Right, now, real quick here, this one is tricky because it's 5 minus this. So whatever this is being subtracted. Technically, right now, there's a negative 1 here, right? So what's going to happen is whatever we get from squaring this has to be multiplied with that negative 1, right? So when I do 3x plus 1 times 3x plus 1, we get 9x squared plus 3x plus 3x plus 1. So we get 9x squared plus 6x plus 1 there. Right? And then all of that has to be multiplied with that negative 1. So we get 5 minus 9x squared minus 6x minus 1. So watch out for these negatives. If the negative is in front of a parenthesis, everything inside of that has to be given that negative sign. Right? My last step, I have two like terms here. 5 minus 1 is 4. So my final answer would be negative 9x squared minus 6x plus 4. So there's that. One more thing I want to show you is this problem, g of f of negative 2. So in this problem, we're putting negative 2 into f, and that answer into g. So first put negative 2 into the f function. So that's 3 times negative 2 plus 1, which would be negative 6 plus 1, which would be negative 5. So now we're going to put negative 5 into the g. So g says to do 5 minus, and it says x squared there. So whatever we're plugging in has to be squared. That's a negative 5. Now notice the parentheses. Anytime you take an x out, you put parentheses where it was supposed to go. Like here, instead of putting 5 minus 3x plus 1 squared, like that, this says only the 1 is being squared, but since x is being squared, that means everything that x is has to be squared. All of it has to be squared. So anytime you take out an x, put parentheses where it was supposed to go. That way you know you're plugging in the right thing and doing things correctly, right? Because negative 5 squared is 25, but negative 5 squared is negative 25. The parentheses change the answer here. Right? If there's parentheses, you get a positive 25. If there's no parentheses, you get a negative 25. Make sure you're using your parentheses correctly so that you get the correct answers. So there's that. I want to show you one more. When you get an or a square root. So we'll have some with square roots like this one. So I want to show you what's going to happen here. So this one's a square root, this one has an exponent. So f of g of x will be f of the square root of x minus 3. The f function is x squared minus 2. So x minus 3 in the square root is getting squared. Now when you square a square root like that, they cancel each other out. So I'm left with x minus 3 minus 2, which is x minus 5. Like that. Right. So that's how you do it with the square roots. Now, if you did g of f of x, we get g of x squared minus 2. That means the x squared minus 2 goes into that square root. So x is supposed to go here, so we're going to put x squared minus 2 there. Right? X squared minus 2 minus 3 would be x squared minus 5. Now, because of this minus 5, the square root wouldn't cancel. If it was just the square root of x squared, it would be x, but because of that 5, it doesn't cancel out anymore. So this would be your final answer here. Right. So there's that. So now it's your turn. So I want you to try this problem and then try this problem. So pause the video, try these two, and then come back and see if you got the answer right. Okay, so the answer to this first one would be f of 4x minus 8, which would be 2 times x minus 3, so 4x minus 8 there, which is 8x minus 16 minus 3, or 8x minus 19. The first one. For the second one, first plug 4 into f, so 2 times 4 minus 3, which is 8. 8 minus 3 is 5. Now plug 5 into g. So 4 times 5 minus 8 would be 20 minus 8, which is 12. So there you go. Alright, so that's composition of functions. So we're going to work on this today. If you had trouble with this lesson, make sure you find